Okay, now next we have is the Doppler's effect in sound. Whenever there is a relative motion between the source of the sound and the observer, there is an apparent change in the frequency of the sound emitted by the source and heard by the observer. So this change in the frequency of the sound, when due to the apparent change in the motion, relative motion between the source of sound and the observer, is called as, that is the effect is called as the Doppler's effect in sound. So this, the equation for the effect is Na, which is equals to V plus minus V naught upon V plus minus Vs into N, where V0 will be the observer with the velocity of the observer, Vs will be the velocity of the source, N will be the frequency of the sound, and Na will be the apparent frequency of the sound. So it depends on the different factors, whether the source is stable, whether the observer is stable, or whether the source is moving to, away or towards the observer, or where the observer is moving away or towards the source. Okay, now firstly we have V not equals to 0, that is the observer is at rest. Okay, so the velocity of the observer becomes 0, and we get is V upon V minus Vs multiplied by N. So that is that minus sign comes when the observer is at rest, so the source is moving towards the observer. Okay, here the observer is at rest and the source is moving towards the observer. If the source is moving away from the observer, then the equation becomes Na equals to V upon V plus Vs multiplied by N. Next thing is, when your source is constant, that is as Vs is at rest, that Vs becomes equals to 0, then you get Na equals to V plus or minus V naught upon V multiplied by N. Then the plus and minus are evenly distributed. When the observer will move towards them, it will become plus, and the one the observer is moving away from them, it will become minus. So the equation is Na equals to V minus V naught upon V multiplied by N. Now suppose if the observer and the source both are at rest, and there is a sound created by the source, and hence so there will be no change in the apparent frequency. The sound heard will be the frequency heard will be same as that of the apparent frequency will be same as that of the frequency of the sound. So Na will be equals to N if the observer and the source both are stable.